Good morning, students. Last class we discussed some of the basic concepts of operators and types of operators. I hope all are safe in your home. I hope everyone follow previous video classes. Okay. So up to now we discuss chapter 6, that is Python fundamentals, okay, related to Python programming language. So coming to operators topic, we discuss arithmetic operators, relational operators, identity operators, and last class we discussed logical operators. Within that logical operators we discuss. So logical operators are and, are, not. These are three fundamental logical operators related to logical operators. So last class we discussed with examples and operator. Today we discuss the remaining two logical operators are not. See, these are called as and logical operator, or logical operator, not logical operators. So these operators are used when you are constructing if there is conditions, for loops, while loops, switch case statements. So that is constructing of decision making statements and loops. We are using these logical operators with relational operators. Already we discussed relational operators greater than, less than, greater than, equal to, not equal to, all these operators. So coming to R operator. So R operator. So this is a logical operator. This one is logical operator. R is a logical operator. So this operator is used in conditional statements. Conditional statements are decision making statements. Decision making statements. That is, and these are operator, logical operator used in loop control structures. Loop control structures with so it returns this and, are, not operators returns either true when you are executing these statements by using this operator. They return either true or false. Either true or false values. Okay. So they return true or false values. So how they can be used in our Python programming, today we explain here. See, these operators, logical operator, R operator, conditional statements are decision making statements. We are using these operators. So it returns either true or false when you are using in condition and loop control structures. So depends on this condition, it returns the value, whether it executes if statement or else part of the program. So depends on this value written by this R operator. So this operator working functionality is by using examples here. So the truth value of truth table or value of our operator is the truth table or truth value of our operator is, suppose operand 1, operand 2, output. Operand 1, operand 2, output. See here, operand 1 is here, the operand 1 is, suppose if the operand 1 is true, the operand 2 is true, both two operands are true, so this operator, R operator, okay, returns true. It returns true. If the first operand is true, the second operand is false, it returns true. So if the first operand false and the second operand true, okay, it returns the value true. Suppose if the first operand false and the second operand also false, it returns false. So here the output, when we consider the R operator, okay, it takes two operands, two or more operands. It works on, when you are using in programs, so it takes two or more operands. So that's why first, suppose we are taking two operands with R operator, the output we construct here. So first operand is true, second operand true, the output returns true. If the first operand true, second operand value false, it returns true. If the first operand false and the second operand true, it returns true. If the first operand false and the second operand also false, then the final output of the return value is false. So when we observe or analyze this truth table of R operator, depends on the operand values. Okay, so here if any one of the, see, we observe here, if the first operand true or second operand true, or see here, you observe, if any one of the operands, out of all the two operands, if any one of the operand is true, the output returned by this operator is true. Suppose if all the operands false, finally it returns the value false. Okay, so next coming to, we observe here, suppose if the first, how this R operator executes or evaluates in, when you are using Python programming language, when you are using in if constructs or for loop constructs. Yes, see, observe, first operand is true, first condition, see here, first condition, first operand returns true. When you are evaluating first operand true, then immediately, why? Because without checking of second condition or second operator, we decide the output value is true. So in this situation, first operand, so first condition evaluates to true means, so R operator, if any one is true, the final output is true. That's why we decide without, okay, without observing or analyze without checking the value of the second operand, then we decide first operand. Okay, finally we decide the output is true. Suppose these two cases, first operand is true, without checking we decide the output value is true. So it not depends on the second condition. So first condition evaluates to true means we not check for second condition. That is the concept of R operator. Not like in AND operator. In AND operator, if the first operator true, we check the value of second condition and we decide the second condition. Depends on the second condition value, we decide the output of the AND operator. But not like that here. R operator decides first we compare the, okay, first condition evaluates to true, then we decide without checking second condition or third condition, we decide the final output is true. Suppose if the first condition is false, first condition is false, then we decide, we compare the second condition or second operator. So depends on the second operator, the final output is decided. So in the previous two entries, without checking second condition or second operator, we decide the output, okay, final output, basing on first operand or first condition. But when the first operand is, when the first operand or first condition is false, then we must and should verify the value of the second comparison, a second condition, a second operator. Why? Because here first is false. Then depends on the second value. Whether it is true, the final output is true. Whether it is false, the final output is false. So the final output here in these two cases depends on the second operand. See, observe here. So when the first operand is true, we not check for the second operand, then we decide the final output here. But in second case, whether first operand returns the value false, then we must and should check the value of second condition, second operator, and depends on the second operator, we decide the final output. If the second operator true, the final output is true. If the second operand is false, the final output is false. So this is the structure of the truth table or truth value of the OR operator. So by using this concept or this truth table, we go through the examples how the OR operator used in our Python programming language. So I am taking one example. If A is greater than B, or A is greater than C, if A is greater than B or A is greater than C, print A is, take a value. Take a value. I am writing here take a value in print statement. Yes, print take B or C value. See this example. So I am writing here one simple code by using the OR operator. See, if A is greater than B or A is greater than C, then we decide. Here we write two conditions. So this first operand, this first condition, this one is second condition. We first evaluate first condition. Suppose if the first condition evaluates to true, then we decide the entire condition is true. Suppose if the first condition evaluates to false, then we must and should check the second condition, and depends on the second condition we decide. Okay, if it is true, the final output is true. If it is false, the final output is false. So in this way we proceed our example. Suppose I am taking here A value. When we run the exam, when we run this code, run the code means our execution. Execute this program. So I am giving A value 10, B value 20 and C value is 30. Then we observe each and every condition here. Here A is, first we evaluate A is greater than B. Here A value is, first we check A is greater than B. See here A is greater than B means 10 is greater than 20 or not. 10 is greater than 20 or not. This one is returns false. This returns false. Why? Because here 10 always less than 20. That's why it returns false. So this value returns false. This value returns false when we are giving 10, 20 and 30 for ABC. So then we decide, then we check this condition. A is greater than C. Why? Because first one is false, then we check the value of second one. So second condition here is greater than C. A means 10 is greater than 30 or not. Here it is also false. That's why this one is also false. This one evaluates to false. This one is evaluates also false. Then we decide the false, false, false or false. False or false means false. The final output is false. That's why. So false means it doesn't display, because if complete condition evaluates to true, this can be printed. Otherwise, suppose it evaluates to false, it prints go for else part and print take B or C value. So output here, the output here, okay, take B or C value. This one is the final output of this code. When you are executing with the value A is 10 and B is 20 and C is 30. So in this way, the OR operator is worked basing on this table, truth table. So I execute the same code with different values. Suppose I am giving here, okay, I am giving here different values. Suppose I am giving A is 30, B is 20 and C is 10. Then we, okay, compare same concept. Okay, then we compare the same concept, same code. Okay, then we compare same code with the different values of A is 30, B is 20 and C is 10. Then we calculate A is greater than B. Suppose if A is greater than B, if A is greater than B, see, check. A value here is 30 is greater than B 20. So 30 is always greater than 20. That's why it returns the value true here. Okay. So if first condition evaluates to true means without checking we decide the final output. The entire output returns true. Why? Because if the first condition evaluates to true, here or here, check these two entries here. If the first one evaluates to true means the final output is always true. Why? Because if any one is true, the final output is always true here. That's why we decide the final output here true. So like that this OR operator works going on. See next. So it prints take A value. Why? Because here the entire condition evaluates to true. That's why it print take A value. Suppose if the condition evaluates to false, then we take. So in this case, it not go through this else part. Okay. In this way it executes. I change my values in. Okay. The next example here. Okay. See, I checked. See here, A value is 20, B value is 30 and C value is, I am giving here 10. In this example, first, so I change my values here once again. So that's why I check one more time here. I am checking the values of this code. So here A is 20, B is 30 and C is 10. So first we compare A is greater than B or not. A is greater than B or not. A means 20 is greater than B. B means 30. So 20 is always less than 30. That's why it returns false. It returns false. So next we compare, it returns false. That's why we check. So if the first operand returns false, then we check the second operand. So second condition. Second input, here operator 1, operand 2 are input values. If the first input value evaluates to false, then we check for second input value. See here, A is greater than C. We check this one. A is greater than C. So here A is 20, and B is and C is greater than C is 10. So 10 is less than always 20 and 20 is greater than always 10. That's why it returns true. In this case, okay, first one evaluates to false, second one evaluates to true. So when we compare third entry, when we check third entry, first one is false, then we decide second condition, the output decides. So here the entire this statement evaluates to true. Why? Because here, so first one is false, then we decide the output here true. The second one is true. That's the reason if the final value of this code returns true. So already we check this condition, we check this condition, we already check this condition. So in this way, this OR operator, okay, works basing on this truth value table. So understand this, understood each and every concept of AND operator and OR operator. We already completed AND operator and OR operator. These two AND OR operators are logical. These are called as logical AND, logical OR. We can write these in English letters AND or OR. Why? Because symbols are there. So different symbols are there. Single ampersand symbol for AND operator, that is used for another bitwise AND. So here two types of ANDs are there, bitwise and logical AND. Today and yesterday we discussed related to AND OR. Those are logical AND and logical OR. So in this way OR operator is executed in computer programming language. Next, coming to NOT operator. So NOT is a logical operator. NOT is a logical operator. So NOT operator. NOT is a logical operator. It is negation. NOT means negation of the given input. Suppose I am giving some value, that value evaluates to true, then it negates the value of that input. So true means it returns false. The output, final output returns false. Suppose I am giving input value false for one condition. Okay. So it negates, NOT operator negates. False means it returns true. So the truth value of or truth table of this NOT operator in logical operators. So the truth table for NOT operator is, so I am taking operator 1 or input operand 1. It's okay, or input 1. This one is output, final output, or input, operand 1 or input 1. See here, okay, suppose true means it returns false, false means it returns true. See, when we observe AND or these two operands works on, these two operands works on two or more input values. Input values. When you observe the truth values or truth tables of AND or operators, okay, AND or operators. So the two or more input values it takes. Okay, but this NOT operator always, okay, takes single input. Always take single input. So this one is unary. It takes single operand means NOT is unary. NOT is unary operator. So always it takes single input. Why? Because it takes single input. It takes single input. That's why it is calling it as single means unary. It takes 2 or. This and or operators always takes more than 2 or more than 1. That is binary or trinary or n-ary. So that's why these and or are not operators are logical operators. This not operator is always take only single input, and or operators are takes more than one operator, that is 2 or more values there takes and returns only one output. See this unary operator not always returns only single output. It takes single input and returns single output. But and or operators takes 2 or more operators takes inputs 2 or more input values and returns only single output. So always these not and or operators returns only single value output, whether it is that is either true or false, depends on when you are giving our input. So this is the today's concept. We discuss few more examples with not operator in tomorrow's class. Thank you, students.